Hey, hello, welcome. We're back. It's us, me and Lars. Where is he? He's here somewhere. And I am broadcasting in 1080p and also forgetting a whole bunch of stuff because I had a week off, so I've absolutely forgotten everything. But Dave Odessa, can you believe it? Here we are in 1080p. Thank you for requesting that multiple times to convince me to do it. Knock wood, it seems to be broadcasting okay. Stream is healthy, says YouTube. And hey, Space Pope. Hey, Dave Odessa over in our YouTube chat. Hey to everyone over in our Discord. Look, that's our Discord right there. So if you are somewhere like Twitch or Facebook and you're wondering where the chat is, head on over to our Discord server, which is at adafruit.it/Discord. You'll get an instant invite. Look for that live broadcast chat channel that you see right there. That's where it's happening. DJ Devon 3, it's true. Broadcasting in actual 1080p this time, and crossing fingers. Excuse me. So if you're not familiar with this in YouTube, at least you can click on your little quality setting down in the bottom right corner on the little gear icon, and it is often set to auto, but sometimes I feel like auto doesn't actually just pick the best, like fastest one. I think that one might be based on your bandwidth or something. I feel like they're doing something sneaky. So if you want to try to watch it in 1080p, click on the 1080p option there. And I feel like that should make some of our code examples much more legible, so hopefully that's the case and it works out for us. I used to broadcast 1080p, then I had a bunch of issues with some bandwidth things that caused me to drop down to 720p, but those seem to be resolved. Sorry, I have a USB cable. I'm trying to thread past something over here. Where are you going? What's that thing doing? All right, that'll work. I was slightly out of breath at the beginning of the show because I ran out to get a Circuit Playground Blue Fruit that I had forgotten I needed for a demo. So that's all set up now. Set this thing over here. So let's see. Since I was off last week, some things are different. I don't have a product pick of the week wrap up to do this week because I'll be getting back on that show next week. So stop by on Tuesday for that. And otherwise, I think I've got a fairly typical slate of things. First of all, I'll let you know I've got a coupon code that you can use today if you want to go to the Adafruit store and buy some cool stuff. You can get 10% off. And that's the coupon code today. It's Blade Runner, not in the real font. I forgot I didn't have that one on here. But close, right? Bold, italic. Blade Runner. That'll get you 10% off in the store, so you can head on over to this place right here. Have you heard of it? That's the Adafruit.com, and the main page is the store. You can then, of course, select from the products sub-menu there, and then pick from categories. You can pick from the new products, little view all there, feature products, view all, or scroll down and just see what shows up. We've got banners and GIFs and blinky things, just to entice you to come and spend some of your hard-earned money on some cool stuff, and we'd love for you to save a little bit. So with that Blade Runner coupon code, you can get 10% off. Just write that down in the coupon code field on your way out. Not only can you save 10%, but you can also get a bunch of free stuff. So depending on how much you spend, if you ever are curious about your freebies that we have on offer, head to adafruit.com/free. And you'll see there we've got, for orders of $99 or more, a half-size Perma-Proto breadboard. For $149 or more, you get a KB2040 and the breadboard. For $199, you get UPS ground shipping in the continental US and the KB2040 and the Perma-Proto. And then if you go all the way up to the $299 or more rate, you'll get a free Circuit Playground Express and the ground shipping and the KB2040 and the Perma-Proto. So you can stack all of those. And in fact, if you keep going, as it says here, for every order you make that exceeds $99 over the course of the promotion, you receive a freebie. So those are stacking there. Andy Calloway asks, what does the 1080p look like on your new TV? I found yet another CRT. It's not in here. I actually have it in my little studio. It's nice. It's 27-inch JVC, and it has the same tube as the D series, which are somewhat legendary among weird CRT people. Legendary tube. It's a curved tube, but it has component in, so it is gorgeous. I was watching the Blu-ray of John Wick 3 on it, and it looks incredible. And also I have a S-video out on my Super Nintendo, and I was playing some Indiana Jones on that, and it looks incredible. Maybe I'll bring that one in here to show off, because it's a gorgeous set. I still don't have the remote for it, so I haven't been able to dig into any of the deeper settings, but it looks really good just with the sort of front panel settings. So anyway, there's your coupon code. Go get yourself some stuff and save 10% off with the coupon code Blade Runner. That's good until midnight tonight. That TV, by the way, is either 480i or 240p, depending on the source. So the 1080p might be a little lost on it. Hey, Mike Billings, welcome to our YouTube chat. You say hello from Michigan. And hey, Brent, our own Brent is here. Nice to see you. Thanks for stopping by. Wave emoji. Dexter says, wow, that's crisp. Oh, good. I'm so glad. I'm so glad the crispness is working here with our 1080p broadcast. Let's see. What else do I have going on? So I don't have a new product pick of the week recap because I was out, but that's the show. That's going to be happening next Tuesday. I've got a new product to share with you, and you'll also get a big discount. I believe it's going to be a 50% off discount, as is our custom with Adafruit products, since we can accept the loss on the margins. Can't really do 50% off on other people's stuff. We don't have the margins for that usually, but with Adafruit products, like the one that's coming up, you will get 50% off, pretty sure. Okay. Next up, let me set up something in the code editor over here. Excuse me. Let's see, I'm going to break things if I try it that way. Let me open something else. Hold on, stand by. Don't save that. Do save this. Close that. And so close. Let's see. How are we looking? Oh, hold on. One more piece of setup to do. Mm-hmm. Almost. Yeah, that'll work. Okay. So that's it. We're ready. Okay. Thank you for your patience. Just getting my coding window set up for CircuitPython parsec. So here we go. CircuitPython parsec. All right. Wow, hold on. I gotta de-warm this white balance. That's wacky. There, that's a little better. I think that saturation is cranked too. And focus. Looks nice. Okay. For the CircuitPython Parsec today, I wanted to show you the Circuit Playground library inside of CircuitPython. So this is a bit of confusing naming, but for the Circuit Playground Bluefruit and the Circuit Playground Express boards, we have a very nice high-level library called Circuit Playground. This is a library that runs inside of CircuitPython and gives you super easy to use commands that are very consistent from one to the next in order to use the features that are specific to these boards. So you can see right now in my code, I have, ignore this commented out stuff, but I have right here two lines, and these are the only things that matter for the most part right here. From Adafruit Circuit Playground, import CP. Excuse me. Try that again. From Adafruit Circuit Playground, import CP, and then cp.redLED equals false. So I'm going to change that to true, and then I'm going to save the code. And what you'll see here is when this reloads, the little red indicator LED up at the top is going to light up red. So you can see that little LED just lit up there. And that is as easy as it gets. You see, I didn't have to declare a pin to be a digital input-output, set its direction, then set the value. It's usually about 3 lines to get that LED lit. You can see another example here where I'm going to use not only the red LED, so you can see here the first thing I'll do is say the red LED equals the opposite of whatever the switch is doing. There's a little switch here. So I can read that switch just by saying cp.switch, what's its value? Then I've got a little variable here that I'm using to save the state so that I can essentially debounce this switch or not have it running all the time. And then in my main loop here, I'm saying if this CP switch is true, then we're going to set the LED off. If it's false, we're going to set the LED on. And that just has to do with the direction of the pull down resistor on that. So you can see here, I'm reading a switch with just this little simple command. If CP switch is true, or if CP switch is false. So these make things really straightforward and easy to use compared to the typical CircuitPython, which is already not bad, but particularly in an educational environment, if you're using these boards, either the Circuit Playground Bluefruit or the Circuit Playground Express, it's a really great way to go. And so that is an introduction to using the Circuit Playground library inside of CircuitPython. And that is your CircuitPython Parsec. All right, I was surprised because I thought surely I've talked about the Circuit Playground library before, and I have not. I had no evidence of any, this is I think the 101st episode or something like that of Circuit Playground, CircuitPython Parsec. Oh my gosh, if I start talking about Circuit Playground, I'm gonna never say either of those words correctly. But no, I haven't gone through it. So I'm gonna do a few of these to give people a little edge up on the game of trying to jump right into CircuitPython using these high-level libraries. And it's not very difficult to then transition to the regular CircuitPython if you want, but there's some really nice conveniences for the buttons, for the switch, for the NeoPixels on there, the LED, I believe the cap touch of these cap touch pins, audio, maybe a couple other things. I think we've got the accelerometer and the light sensor. So a bunch of easy ways to use CircuitPython for a beginner that I think are pretty helpful. Yeah, DJ Devon 3, I have a lot on MakeCode. Yeah, I did a lot of the MakeCode minutes on these boards, particularly because the main Adafruit MakeCode ran just on the Circuit Playground Express at first. But somehow I never did the Circuit Playground inside of CircuitPython, so here we go. All right, let me get that out of there, and Perthic Cyclone. I haven't said it that way yet, probably, but maybe. Let's see, what else is next? Okay, so project that I've been working on. This is the reason that our coupon code is Blade Runner today. And don't forget, you can get 10% off in the store if you use that coupon code. The reason is the Tyrell building inside of CircuitPython, inside of Blade Runner, is a gorgeous, iconic sci-fi structure. In fact, let me pull up a nice image of it. Tyrell building. Sure, this will do. Okay, here's a bunch of them for you. So this enormous, enormous building, you can see there's a image right there with a little spinner car flying towards it. This thing is just huge. In fact, this is a image from the model that was built by the model shop. These are some nice images to give you an idea of. This is practically lit using fiber optics. Huge. I don't know how high it stands, off of maybe 4 feet off of the deck of the table it was built on. You can see someone working, one of the modelers working on it. And it's this beautiful design by Sid Mead that was meant to show sort of the layers of time. So initially it's just this sort of pyramid shape, and then it adds these extra 8 towers around the front, and this is just this enormous, enormous building. And it's kind of an iconic sci-fi piece of architecture. And as we've been working with the Synth.io library in CircuitPython, our good friend Todd Kurt was doing some studies in porting synth code he had written in Mozzie on Arduino over to Synth.io. One of them was called 80s Dystopian Synth. So if you look at this, this code right here, this is from Todd's CircuitPython Synth.io tricks page. It's called 80s Dystopia. And my favorite part about it is the description at the top. I'm going to turn off my HVAC here because I'm going to do some sound demos in a second. This description at the top, it says, a swirling, ominous wub that evolves over time. No user input, just wallow in the sound. Dexter just said mic check. Was there an issue? Let me know over in the chat if there's if the mic seems to be working well here. I have a second mic I'm going to turn on when I do some sound demos in a second here. But so that's Todd's code there, and he's also got a nice demo that he originally posted on YouTube of that playing, and mine is going to sound basically the same. So rather than play that through the speakers, I'll play that for you directly in a second. So you're saying the mic went quiet, huh? Did it just go slightly quieter, or go way, way quiet? Okay, it went quiet suddenly. Weird. Why is that? I've got fresh batteries everywhere. That looks like it's gaff taped to my shirt pretty well, right? All right, sounds good here. Okay, let me know if you have any other issues. The basic circuit for this is, I'm going to show you my little prototype, is a cutie pie. Let me grab something to point with here. So we've got a cutie pie right here, and then really all you need for this one is a PWM output. So sometimes we'll do I2S audio and a special I2S amp, but for this one, you can do a pretty good job just twiddling a couple of PWM pins and actually get stereo. The only thing that you want to do is to sort of smooth out aliasing. There's like little stepping in the PWM. Smooth out that aliasing a little bit with an RC circuit. So you have a resistor and a capacitor going to ground, resistor going to the audio output. And then I'm using our little TRRS jack here. I'm actually using it in TRS mode, so with a 3 conductor sort of regular stereo cable, of which usually I have a million of them, and now I can't find any. But we'll plug that in later. So the left channel and right channel that we have here coming from 2 different PWM pins. Those have to be a PWM pair, and there's an A and a B in the pairs of pins as defined on the chip. So in this case, on the QT Py RP2040, I'm using a TX pin as the left channel over here, and then the right channel is the RX pin there. And then that's enough to play this, to do stuff in stereo. I'm actually not doing anything in stereo yet in this. It's just preliminary. I'm going to adjust the code to do some kind of panning effects to move the sound left and right. But then you can see I've got a bazillion resistors here. What is this all about? Well, I wanted to do capacitive touch. So if I zoom out a little bit here, you can see I've got these roughly 1 mega ohm, I think these are 1.5 mega ohm resistors going to ground from each pin that's going to be used with cap touch. And then any kind of capacitive touch wire, copper tape, anything conductive that can act essentially as the sensor for the capacitance. And this is not resistive touch, so you don't actually have to have contact with it. You can put it underneath a piece of plastic, cloth, paper, paint. So it's kind of a cool way to use an interface. And I've got, since I have 8 of these, I'm going to use these essentially as pairs of 4 pairs of increase or decrease of a parameter. So the first one that I have set up just allows us to transpose the essentially the key that we're going to be playing the music in up or down within a list of root notes. And then I can use another pair for something like volume, another pair for something like the speed of the LFO that modulates our filter, and maybe one as a filter parameter or something like that. So that's the basic design, and what I did was I took that and smushed it down onto a quarter-size permaproto board. So you can see it there. I've got some wiring coming off of it, but that is the same circuit, just kind of mushed down to about half the size. And I also built this a little bit 3-dimensionally just to deal with space constraints. So you can see here I have some feather header pins, these little short stacking headers. I didn't want the full height header pins, but I got the short stacking ones so that my I2, or not I2S, my TRS or TRS jack output can be flipped and sort of floating above the QT Py a little bit. I also still have access to the Stemma QT cable, hey bug, if I want to attach any other peripherals to this. But you can see here I'm using a little right angle TRS cable, which, there we go, there's the tip ring sleeve, and those are acting as a ground, a left channel and a right channel. And then I'm also, you can see here, using some headers to break out my pins for the capacitive touch. So I'm going to just use some jumpers. That just makes it possible to connect this up after it's been partly assembled into the case. I didn't want to wire directly to those so that I can make assembly a little easier. And then again, to fit things in a constrained space, I'm using a little right angle USB-C cable here, just because that doesn't protrude out as far. But that's the basic circuit there. And then the idea I mentioned with this Tyrell building is to build this as a desktop synthesizer inside of a little model of the Tyrell building. And so I'm going to hold that up at a sort of more attractive angle. Oh, let me get some better lighting too. Hold on. There we go. Something like that there. So you can see I've made a little 3D model. I'm going to bump the exposure up. It's a little dark. So I've built a little 3D model here of the building, and I have a nice big space inside of it to place all of the electronics. And you'll see here I also have 8 little holes that I modeled into it to run the wiring for capacitive touch. And then I have copper tape that I'm using as my capacitive touch antennas there. And so I've got space for 8 of those. I may just go with this as a design. It kind of looks cool. I'm not doing a one-to-one copy by any means of the original. But these could, if you wanted to, be underneath the surface of either a little cap, 3D printed cap that you place on top of that, or paint or something like that if you want. So that's the case for that. And then I also just, fresh off the printer, made a little bottom plate to go under here. And that'll fit in there like that. And then I'll screw the quarter-size permaproto to these two. I offset these a little just to get the USB coming sort of straight out the middle. And then I have 4 little corner screws here. This actually, I don't think I'll be able to close this up properly because I just made some temporary screw holes there, and I forgot to actually go in and either size them a little smaller than the screw and thread them, or make them big enough for some heat set inserts. So I may have to either use M3 screws and bore these holes out a little bit on this, or reprint this model right here. So that's the basic design of it there. And what I wanted to do before I play it for you is talk a little bit about what makes this code so cool in Todd's original. So let's jump back to about this here, and I'm going to plug in, let's see, let's plug this one in. So I'm just going to plug that one in right now. I think I have the same code running on both. Yeah, you know what's funny is I didn't really intend to do like a lot of detail. This is more of a suggestion of the shape. I just really the only surface detail I gave it was the little grooves here to align the tape properly. But you can see as you mush down that tape in there, you get little imperfections of the 3D model that look kind of nice and like higher level of detail of very small things that helps give the thing some scale. So if you look at the code, let me open this. Okay, yeah, it reloaded. If you look at the code here, the comment here that says code 5 detuned oscillators are randomly detuned, I think that was every second or so. And then there's a low-pass filter modulating over them. The filter rate changes randomly. And then originally in this, I think I changed this, but every 15 seconds it would change the note. So this notion of the detuned oscillators is really important, and I wanted to do a fairly quick demo of this. So let's, excuse me, let me switch over to this view. So I've got a little, not so little, I've got a big Roland electric piano. This was not really they didn't really consider this to be a synthesizer in the way that their Juno 60, which was, I think came out the same time, and therefore you can tell it has a lot of the same design cues. This was less expensive, and this was just meant to be sort of a, oh, is that camera really dark? Oh no, I think that's my monitor. My monitor's backlight is dying. I was like, wow, it's really dark right here. I don't think that's it. So this is essentially a 2-voice synthesizer. And I'm going to check my meter. Let me know if you can hear that pretty well and you can hear me pretty well as I play demo and try to explain stuff. So I'm just going to play some stuff and talk here for a moment, and then I can check my Discord. Let me set lower hold on here. So I'll let that play and open up my Discord. Let's see. Sounds good. Okay, good, so you can hear. Okay, so let me take the hold off of this. So this thing, it plays 2 oscillators, and you can hear just one oscillator right now because I have this balance set to channel A. Actually, let me turn off arpeggios too, and I'll just play a single note. Here is the second oscillator. It sounds identical, and in fact, right now I have them with using the same voice, the same synthesizer voice, so I can change one of these. So that's what the B channel sounds like, and that's what the A channel sounds like. And then I can play a mix of those. So you'll hear those 2 notes happening at once. So I'm going to make these the same note, and what you'll notice just happened, I'm going to output, is there's a little bit of motion happening because these are not perfectly in tune. So it's 2 oscillators, but they're slightly detuned. So what I'm going to do is I'm going to try to get them as close to in tune as I can. And I want to, let me boost this even. That's a little better. Okay. Okay, that's pretty well in tune. Now watch what happens when I detune just one of them. So I can go in here and change the tuning of just that channel, this B channel. Okay, so it's A and B in tune with each other. Now what I'm going to do is I'm going to play them both together, and I'm going to slowly detune just the B channel. Right, so if I detune it enough, it's just a semitone apart, so it sounds like I'm playing 2 notes. But if I detune it less than that, let's say a quarter of the way, we get this chorusing effect, which is the fact that there's slightly out of phase, very similar frequencies that are slightly out of phase with each other that we're hearing. So if we, let me play around a little bit with some of the equalizer, the EQ over here, and some arpeggios, you'll hear kind of the idea or some chords of this sort of fat dystopian sound that Todd was going for. A little hot on my output, hold on. Now listen what happens when I tune these back up. It's a little square sounding, even though this thing doesn't have much, has no effects, but just that one thing of being able to detune 2 oscillators is really powerful. Now I'll detune them. Fattens it up, wow, 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 we get that nice sound. wah, 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 wah. All that shimmery kind of chorusy stuff is what the detuning does. So it's a super powerful effect. Really glad that Todd explored that in his code there. And I just wanted to demonstrate just that one simple thing. Also, by the way, we can get this to happen even when we're not even playing the same note or the same octave. So I'll switch. Here's, so you can hear I have a higher note. Let me just play single note. So single note, 2 channels, 2 voices, but they're basically in tune. Now I'm going to detune 1. All right, put them in the same octave. And drop them both. Oh, that one's actually nice. It doesn't have many harmonics, so you can really hear it. Starts to sound almost like a chord, even though it's a single note, because it is. So that, let me kill that second mic there now, and I'm gonna move that. Am I gonna leave that? You know what? I'll leave that there for a moment, and I think I'll play this synth over here. Yeah. So let me come back to this one right here. Let me throw a desktop right there. Just put me in the corner. So let's play this one. In fact, this one's set up. So what I need is, I'm going to reuse this cable right here. So I have a little pair of powered speakers here. So you're not going to hear this unless I move that mic. You won't hear this as clearly. You'll just hear this from my lav. Let me see if I can get this set up here. I'll move that microphone. So let's get this started. Yeah, I'm gonna grab a different mic stand and move that mic over here. Why not? It's worth it. So you can hear those multitude of detuned oscillations there that sound so cool. You'll hear them better in a second here. All right, let me know how that sounds now we've got proper miking going on there. Should be much thicker. And what I'll do is I'm going to pop open code here and show you a couple things. So first of all, I've got my touch pins set up. So now the possible set of notes that it can randomize through have been transposed. So I'm just taking whatever notes it wants to pick among, which is a small little group, it's just 3 notes, but it's now all been transposed. So that's how I'm using all of these capacitive touch pads right now. But I'll be able to change this so that it's a pair moving up or down my transpose list, or increasing, decreasing volume, increasing, decreasing rate, all that. So let me do a couple of things you can hear and see. So first of all, note duration. Let's shorten that. Sorry for the... So you can see it's just every 2 seconds moving to a different note, but the detune phasing, chorusing effect, as well as the low-pass filter modulation is all the same, staying the same here. If we jump down to one voice, just get this big fat bass. Let's go to 2. Sorry. I know we can do 5. Can we do 6? Ooh, yeah. Can we do 10? Sounds a little noisy. I'm going to drop back down to 6. Again, sorry for that noise it makes. And the note offset list here is what I created to just do my transposing. So I didn't make it just semitones. I picked a little pattern of offsets that I thought would sound good as you work your way through them. And that's just bumped up the list of random notes that it can pick through. There's also some cool Rainbow I/O stuff going on the LED there. See that little color changing right there. See the reflection of my thumb better than the LED itself. And we can, let's see, let's set, can we do floats on this? We can. Let's make it real fast. Oh yeah, run. The cops are coming. It's such a cyberpunk dystopia. I'll tell you, while I've been working on it, I've just been playing it, and I kind of love it. I kind of love it as background music as I work. So great job, Todd. Thanks for creating this. Let's see. I think that's all there is to say while we demo it right now. Let me pause this. By the way, you can see here let me slow this down again. You can see the notes that it's playing here. It's also letting us know. Oh, did it break you? I've broken it. Let me reset it. Should be good. There we go. So as that filter frequency is changing, you can see that show up, and then the notes that are being played are listed out here. So the slight detuning is things like 58.49 and 58.94 hertz. Those are just slightly out of phase. Yeah, actually playing it like that makes me think it would be fun to do a version of it where it doesn't advance until you tap one of the cap touch pads, or you can adjust the tempo, the timing of that sort of auto play that it does. Let's see. So let's talk about this case. I'm going to jump back over here. Let me turn this mic off. I'm going to jump back over to the bench here for a second and clean this up. And get that out of the way, and then we'll take a look at how this is going together. This was a fun, by the way, sort of slight restoration I did on this. Someone I know in the sort of synth community in LA gave me this. They had used it for a while. Someone else had given it to them. Original owner who got it back in 1982 or whenever. And it worked well, just there was a few notes that wouldn't play, and then there's a missing knob, which I didn't find an exact replica for. I just replaced it with something I had that I'd pulled off an organ I found on the street. And then I had to just clean up all the faders and pots using some deoxit, clean it out. And one of the funny things is this was, you know, a nice quality, not cheap gizmo. It's got a plywood base, just black painted plywood. That's original. That's not some restoration someone did, as far as I know. So these were not made the same way as they are today, but in many ways that's a good thing. This thing is really nice and heavy and sturdy. It's built like a tank, all folded steel for the chassis here. So I'm going to take this and put this right here. Okay, get the danger high voltage tray out of there. And good, okay, can I switch to this view? That looks good. That's for dusting the synth. So here is the first version that I made, and this one has I've removed 2 of the wires, but this has 6 of the capacitive touch wires in there, and you can see I used some jumper wires, DuPont connectors that can plug in, and I also grabbed some of my very old copper tape that the adhesive had died on, so all these are peeling off really terribly, but I found a nice new one I had in a Ziploc, so it's much more adhesive. But you can see here the basic idea is that I push a cable through the little holes I modeled into it, strip the insulation, lay that there, and then put the copper tape over the top of it. That's how that part there goes together. And let's just show you the, even though I only have 2 of these in place right now, let me show you what the assembly of this is going to look like. One second. I think I have a longer right angle USB-C cable that I can use, but this one I kind of like the idea of it just having this little pigtail coming out, and then I can use a USB-A extender to plug that into the computer or into power. So here was a previous one, and by the way, this was one where I had I've been a little optimistic about how far back the parts could go and not bump into the wall inside the pyramid. So to test, I measured and decided I was going to go 6 millimeters further, but I decided to drill those and test those because at first I had done 10 and that was too much. So drilling your 3D printed part that takes an hour to print just takes a few seconds, and it's kind of a nice way to test things out before you commit it to 3D printing. Pyramid's taking about 6 hours to print right now, and that's using support because I wanted to, since I added the little inset. Oh, let me turn this light on. Was this unplugged? Why is that off? Huh. Oh. That's why, maybe. There we go. Some extra light. By the way, you'll see this little dot here. That's from a sunlight coming in through a vent hood, so it'll appear and reappear because the vent hood's spinning. So let me unscrew that there. So these are temporary screws. And I think I'm going to use the black nylon ones because the head is what I measured, and these are a little too big. But these are just temporarily to see if I've got the spacing right. Like so, and like so. And then curl that around like that. Headphone goes in here. These will plug in to the little headers. I won't do that right now. And then that'll fit in like that. So the proper, when I use the black nylon screws, those will countersink down in, so this whole bottom will be flat. And that will be power or data and power and sound coming off of there. Let's see if I can focus that a little bit better there, especially because we have the 1080p. So that's going to be it. You'll be able to leave that on your desktop and just tap these to make adjustments to it. This wire at the top is just temporarily poking out, but you will be able to see LEDs lighting up in there. In fact, let me grab a battery real quick. You can see the little color shift going on the RGB LED. That's just on the QT Py there. And this, in fact, I don't have the cap touch stuff hooked up, but that will, that's making noise right now. If I don't think I have the right adapters. Let's see if this will make sound or not. There we go. No cap touch right now. Yeah. All right. Awesome job, Todd, on the code, and Jepler and other people working on the Synth.io library. Incredible. So exciting that we can do that right inside of CircuitPython now. All right, let's see. Let me look and see if anyone has any questions. I'm going to turn the HVAC back on because it is starting to cook in here. And I'm done playing sound demos. And let's see. Kane Pat, hi all, hello. Nice to see you over there in the YouTube chat. Thanks for stopping in. Hey, Johnny Bergdahl, nice to see you. And in our Discord, yeah, Toddbot is out. He's on vacation right now too, so he's not watching the show, but he deserves all praise for that coolness right there. So very nice. Oh, thank you. So there was a question from Dexter. Will this run on ESP32 S2 Feather? And I don't actually know the answer to that. I think it will, but let's see. There's a doc that DJ Devon 3 shared, or a web page rather, that DJ Devon 3 shared. And I can go to that. And this should tell you all the boards it'll run on. Where does it tell you that? Can you say that at the bottom? Why do I feel like that's at the bottom? It is not. All right. Is it here and I'm just missing it? Available on these boards. Oh, so it's a little drop down at the very top. So Feather ESP32S2 is a go. Yeah, so there's the TFT version, the reverse TFT version, and the S2 version. It just doesn't have a hyphen in the name. So let's see. Yeah, in general, this will run on ESP32. This will run on RP2040, STM32, NRF52840. So if you had any Bluetooth needs, that might be a good one. M4, it's a Itsy M4. I'm assuming Feather M4. I didn't see it there, but Matrix Portal. So yeah, even some of the, I didn't know, did we have ESP32 Pico? Do we have? I didn't know we had CircuitPython on that. I think I knew that and I forgot, actually. I keep forgetting that. So yeah, no M0, no, what else is missing from this of our main boards? But yeah, most of them are on there. So I have mostly been running it on the M7 and on the RP2040. It's running great on those. Thank you for the link, DJ Devon3. All right, that's going to do it for the Tyrell desk synth. I'll be documenting that and putting out a guide and sharing the 3D model I built for that. Oh, you know what? Let's see. I don't mind running a little over if you don't mind. Since I've got 1080p now, I wanted to show you the model just to open other. Let me show you just a kind of a clipping view through the model here in Rhino. Blade Runner Synth, Tyrell, version 0.6. There we go. Let's share that down here. 1 second. Screen capture. New screen capture. Black hole. Rhino. Okay. So there you go. Sorry, I have these massively thick lines on here from something I was showing at one point, which is kind of funny looking, but that won't hurt anything, I don't think. Let's just put a clipping plane that we can push through the model here. This just makes it easier, I think, to see, for example, behind these pillars, which I've got some support right there holding those in place. You can see there's the holes that pop up for the wiring for the cap touch. And you can see those holes just are like a little tube running down and through. I modeled a temporary stand-in. This Cutie Pie is an excellent model from the Ruiz brothers. I did a very temporary stand-in of the TRRS breakout there just for size, so I could kind of see where we fit in there. You can see it's it's a close fit, but I think it works now in that new position. And there you can see another one of those tubes there. Tyeth says 1080p and an extra long broadcast. You're spoiling us. These are the holes that I mentioned. Let me just move that out of the way there. So the mounting holes that I mentioned are, I just made them like 2.7 millimeter, which is the size of the hole that I just put the screw through. That means it won't grab the screw. So I will probably do two versions, one with threading, even though at 0.15 millimeter layer height, that threading is a little rough. You can still, it's a nice way to screw the nylon screws into it, work pretty well. And I may do a second version where I expand that for 2.5, M2.5 heat set inserts, threaded inserts, so that you can open it and close it up. But yeah, those are the little holes there for screwing in from under the bottom. And you can also, here, let me flip this, do a little growth sequence here. So that's essentially what your 3D print is going to work like. And you can do this without support if you want. But I think now that I have this lip here for putting the base in, you kind of want that to be neat. So printing it with support helps that. You don't really need the one. There's going to be some support up in the chimney there. You don't really need it there, but mine printed with like a little column, a little chimney going up to there. That's okay if that's rough on the bottom since you won't see it. And the only other support that it'll probably do is for this USB cutout here for the USB. But otherwise, that prints pretty nicely straightforward, which I'm happy about. The other thought is I might just do it bigger, which means less worrying about exact fit of stuff, and it kind of be nice to have it bigger. Could go quite a bit bigger even, have like a big, massive thing, put some weight into it, would be kind of cool. Andy Calloway says, this is a 3D Hangouts segment of John Park's Workshop. That it is. And then, let me see, the last thing I can do is if I open up, I don't think you'll see this unless I share the Grasshopper window, but you can see how this is built. Let me open up the Grasshopper script. So the Grasshopper is sort of the procedural parametric modeling workflow that I used. So it starts from curves, basically. And let me get rid of the clipping plane, and I'll hide these baked models. So these are the models that I baked off to print. Get rid of the electronics there. So let me hide these. And so if I step through, there we go. So these are some curves that I lofted to make those pillars. Like that. Then I use some mirroring to make all of the 4 that I need. So it means if I make one change to one of those curves, it'll propagate to the rest. Then for the pyramid itself, I actually lofted some curves into this shape, capped it, cut out some little columns out of there, carved the inside out, carved that chimney out of the top, combined these things, scaled it all up bigger, which was easier to do at that step rather than go and fix my curves, which probably I should have, but I was being lazy. Here's my little cutout for the USB there. These are my little cutouts, same mirroring and reflection array there, so I can just trim those little grooves out. These are same sort of thing. That's what cuts the wire holes out. So you can see those now have these little tubes there. Whoa, what did I do? I'm breaking things. This is the little bottom that I built there, and I used a version of that to also carve out the base that it'll fit, a little slight offset. And that's with these little countersunk holes, which are incredibly thin, I know, That's ridiculous. But it seems to print okay. You just wouldn't want to put a lot of, you don't want to torque that down too much. And there is the final model, and the final model with the bass is those two. And if we go back to this baked version, we can probably, let's see how well, I don't know how well this machine will do a real-time render. Let's find out. Oh, much better than my other machine, actually. Hey, how about that? I should be using this one. That's fast. These are nice. I like these ambient occlusion types of renders. It makes it easier to see certain details, how they relate to each other. Let's see, how does it like these electronics in here? Whoa, why do we have two? Oh, these are rendered too. Oh, let me hide those. Even faster now, yeah, so. They're a little scrunched in there, but it works. Okay, so that's the model. And I think that's going to do it. Thanks, everyone, for coming and hanging out today. We've got a deep dive with Foamy Guy tomorrow and on his channel Saturday, I believe. Someone asked in the YouTube chat, what program are you using for the building design? I'm using Rhino from McNeil Associates. It is a NURBS and spline and polygon and subdivision surface modeling program that has a parametric workflow, which I wasn't showing there. I can show that real quick. That is used for these types of parametric designs, a workflow like that. Let me share a screen capture. You can see it right there peeking out. Little nodes with attributes that are connected. That and that and that. Okay. So that's what's making that, is those nodes there, which just essentially is a different interface than the usual graphical interface of going in and hand drawing stuff and cutting things. It just, that Grasshopper accesses that, as well as being able to do more stuff, and you can make custom Python code in it and other languages. So plugins, all that. I use it, and I've been using it since something like 1998, so I'm super comfortable with it. I don't always recommend it to people because it's not free. It costs, I think, about $1,000 for a license. However, it's not a subscription, so you can run that license for a long time. But for people who want to jump into something that's at least semi-free, I think Fusion 360 might still be free for some parts of it and pay subscription for other parts of it. FreeCAD is that one, OpenSCAD. There's a bunch of CAD software out there that I always want to mention so people don't say, why are you telling us to buy expensive software? But truth be told, it's a tool that I use and have used for a long time, and I love it, so that's Rhino. All right. Is that it? Does that do it? So yeah, I'll be back next Tuesday with another product pick of the week. We'll have a 3D Hangouts on Wednesday, and a show and tell and ask an engineer, and then we will continue on. So thanks again for stopping by. If you want to go buy some stuff in the store, that's what keeps these lights on, sort of, and that's how we get paid. You can get 10% off on your purchase, and that is for any goods, no gift certificates, software, or gifts or subscriptions, but on actual stuff, you can do that. Oh, and some nice mention, big fan of Blender. Should always mention Blender. Blender is really similar to the software I used when I worked in animation, which is Maya, but it's open source. It's got tons of add-ons that give it parametric CAD-like things and more and more. So definitely check out Blender. At its core, it's not this type of CAD software. Rhino kind of lives in a weird space, actually. It's not even exactly CAD software either, but I think Blender has plugins and add-ons and workflows that can do very similar stuff. So, all right, thanks everyone for stopping by. Nice to see you all in our chats. Thanks, Dave Odessa. I'm glad you enjoyed it in 1080p, and thanks again for encouraging me to do that. And I will check out the rest of the chat comments later. Thanks everyone for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Thanks, and I'll see you next time. Bye-bye.